Hello friends, myself already Mahajan presenting my one more video on numerical differentiation. Let us see the problem. Find dy by dx and d2y by dx square at x is equal to 1.7 for the given data. That given data is values of x and corresponding y are values of x are 1.0, 1.2, 1.4, 1.6 and 1.8. Difference is of 0.2 equispace. Means we can use Newton's interpolation formula to find this numerical differentiation. Corresponding values of y are 0, 0.128, 0.544, 1.296, 2.432. To find this dy by dx and d2y by dx square, I will perform in two parts. In first part, I will calculate the value of dy by dx, and in second part, I will calculate the value of d2y by dx square. For that, first of all, I will prepare the forward difference table. Preparing the forward difference table, first difference 0.128 minus 0, we get 0.128. 0.544 minus 0.128 as 0.416. Then 1.296 minus 0.544, that difference is 0.752, and 2.432 minus 1.296 is 1.136. These are the first forward differences. Taking the differences of this difference, we get second order difference as 0.416 minus 0.128 as 0.298. Then 0.752 minus 0.416 as 0.336. 1.136 minus 0.752 as 0.384. Next, third order difference is the difference of the second order differences. 0.336 minus 0.298 as 0.038. 0.384 minus 0.336 as 0.048. And then fourth order difference is 0.048 minus 0.038 as 0.01. Then we try to find out the value of p. Here that 1.7 is in between 1.6 and 1.8, which is at the bottom of the table, and therefore as it is at the bottom of the table, where to apply formula for dy by dx and d2y by dx square obtained using Newton's backward interpolation formula, and therefore the same table we can use as a backward difference, and therefore p is equal to x minus xn divided by h. Here the value of x is 1.7 minus xn. Xn is the last value from the table, it is 1.8, and divided by h, difference is of 0.2. Therefore it is 0.1 divided by 0.2, 1 by 2. 1 by 2 is nothing but 0.5 with minus sign. Therefore the value of p is minus 0.5. And then applying that formula for dy by dx. Formula dy by dx at x is equal to 1.7 is obtained by formula 1 by h into multiplied by terms in the brackets del yn, del here inverse operator for backward difference, plus 2p plus 1 divided by 2 factorial into del square yn, plus 3p square plus 6p plus 6 divided by 3 factorial into del cube yn. Next, 4p cube plus 18p square plus 22p plus 6 by 4 factorial into del raised to 4 yn, and so on. Then substituting the corresponding values, here h is 0.2, therefore 1 upon 0.2. Next, del yn, I have underlined the last row. This is xn, yn, del square yn, del cube yn, and del raised to 4 yn in red color. And therefore Del yn is 1.136 from the table. 1.136 plus 2p plus 1. The value of p is minus 0.5 into 2 plus 1 divided by 2 factorial into del square yn. The value of del square yn is 0.384. Next, plus 3p square minus 0.5 square plus 6p, 6 into minus 0.5 plus 6 multiplied by del cube yn. The value of del cube yn is 0.048. Therefore, it is into 0.048. Next, plus 4p cube, 4 into minus 0.5 cube, plus 18p square, 18 into minus 0.5 square, plus 22p, 22 into minus 0.5, plus 6 whole divided by 4 factorial into del raised to 4. The value of del raised to 4 is 0.01. And next step is the simplification for this. Therefore, with the help of calculator, we get that values as it is 1.136. I will keep as it is. Then this one is 1 minus 2 into 0.5 divided by 2 factorial and multiplied by 0.384. That value is coming as 0. Next, 3 into minus 0.5 square plus 6 into minus 0.5 plus 6 and whole divided by 3 factorial. Into 0.048. If you simplify it by calculator, we get that minus 0.002. And then next, 4 into minus 0.5 cube plus 18 into minus 0.5 square plus 22 into minus 0.5 plus 6 whole divided by 4 factorial is 24 and multiply by 0.01. That value 0.000. And therefore, if we perform the addition of all these values, we get the final value as. Therefore, the value of dy by dx at 1.7 is 5.67 obtained with the help of this formula. In second part or next part, I will perform the calculation for d2y by dx square. To find the value of d2y by dx square using this formula, d2y by dx square is equals to 1 by h square del square yn plus 6p plus 6 by 3 factorial del cube yn, and next 12p square plus 36p plus 22 divided by 4 factorial into del raised to 4 yn. All these results I have discussed in my previous video. Therefore, using this result and then substituting the value, therefore we get d2y by dx square at x is equal to 1.7 as 1 by h square, h is 0.2 whole square, 1 upon 0.2 whole square multiplied by del square yn. The value of del square yn is 0.384 plus 6 we can take common, cancel with this 3 factorial 6 Therefore, the remaining terms are p plus 1. The value of p is minus 0.5 plus 1 into del cube. The value of del cube is 0.048. Next, 12 into p square. 12 into minus 0.5 square plus 36p, 36 into minus 0.5 plus 22 whole divided by 4 factorial is 24 into del raised to 4. The value of del raised to 4 is 0.01. And then simplifying it with the help of calculator, we get 1 upon 0.2 square. 0.2 square is 0.04. 0.384 as it is, no change. 1 minus 0.5 is 0.5 multiplied by 0.048, 0.024. Next, 12 into minus 0.5 square plus 36 into minus 0.5 plus 22 divided by 24 and multiplied by 0.01, 0.003. And then adding this 3 and dividing by 0.04, we get 10.275 is the value of d2y by dx square, or the answer for this problem. Therefore, this is the value of a second order derivative at the point 1.7, which is in between 1.6 and 1.8. Therefore, applying the corresponding formulas. In my next video, I will discuss another important topic, that is numerical integration. First point from it, trapezoidal rule to evaluate that definite integral. If you like my video, please share it as well as subscribe to my channel to receive a notification for my new videos. For that, press the bell icon. Thank you.